All right, we are here with section 10.3. So we just finished that warm-up activity where we looked for the subcommittees of people. And I have a question for us to think about of why does the sequential counting principle not work for this example that we just did in the activity? And that's what we're going to talk about in this video now. So I want to actually focus on this board first and think about, well, if it did work with sequential counting, what would the sequential counting have looked like? Well, we probably would have thought about the fact that from these 5 people, we're trying to pick 3 people. So I would have 3 blanks. So if we put those down, then if I had to label them, I would really label them as like person 1, person 2, person 3. And if we think about, well, how many options for the first person? Well, we would have 5 different options. There was 5 total people. And then I can't pick the same person again. So then for the next one, we'd have 4 options and then 3 options. And sequential counting would say, multiply those together to get the total. But here's the problem. If I multiply 5 times 4 times 3, I get 60. Which is far too many. When we actually counted it, when we actually looked for those subcommittees of people, we only had 10 subcommittees. Which means that something here is going wrong. Somehow it's overcounting the things that we're trying to count. So I want to look at an example to think about why this is overcounting. Well, in sequential counting, it would do something like, let's look at an example of what it could have picked. So the first person, this person 1, it could have, say, picked Leslie as that person. And then maybe for person 2, it went ahead and it picked, let's say, Jerry. And then for person 3, let's say that it picked Ron. So this is an example. But notice that sequential counting principle would then also consider, so sequential counting principle considers something like, well, let's say that we still picked Leslie first, but then we picked Ron, and then we picked Jerry. Notice that if the order is important, if it really is a sequence of people, if it's really this list of events, then these would be different. So sequential counting considers this to be different than the one that we found above. But if we think about it, right, if they're just a committee of people, well, those are the same committee of people, right? As a group, they're the same group of people. So in this example, these are both the same group of people. So we don't want to count them as different. We just want to count this group of people one time. So we don't want to count them as different. If we think about what else it would have counted as the same, so sequential counting principle says that if we did this, LJR, that's the same as LRJ. And then that would be the same as, say, picking J first, and then Leslie, and then Ron. Or picking Jerry, and then Ron, and then Leslie. Or we also have the option of picking Ron first, then say Leslie and Jerry, or Ron and then Jerry and then Leslie. Sequential counting principle says these are all the same, or these are all different, excuse me. but as a group, these are the same. So one of the things that I want us to notice a little bit, what we're going to do later on in this section is we're going to look for kind of how to describe this scenario, this type of scenario that we're trying to count. And then we're going to learn a new counting technique. So we're going to learn a new way of counting it. And this sort of motivates us a little bit of why the formula we're going to learn works the way that it does. Because what we see is, notice sequential counting started with a total of 60, when really there were only 10 distinct groups. And notice what sequential counting does is it takes one distinct group with this pair or this triple of people, and it counts it 6 times. So every single distinct group got counted 6 times by sequential counting, whereas I only wanted each of them to be counted once. So really what happened was we ended up doing 60 divided by 6. So we're going to see that in a later video. We'll see that show up again. But one of the big things that I kind of want to describe with this example of what's different, right? What's different here versus sequential counting is that in this example, when we're looking for a subcommittee, which could also sound like a lot of different things, right? A group of things, a team of things, a collection of things. There's no specific order or sequence that we choose the people or the things in. Whereas in sequential counting principle, having something that is in sequence is necessary for that type of problem, right? It's necessary to be able to call the first thing, to have a thing, this first one, then another one, then another one, to have some sort of separation between those things, some sort of distinction between the different things. Whereas what we have here is we really don't have multiple events. We don't have distinctions between the different people. It's just one event. Pick the whole group. Because all the things or the people in the group do the same thing. They're not distinguished from one another. It just matters that they're in the group together. So we're just picking a whole group all at once, all together from the larger group of things. So that's the big thing to take away. Sequential counting requires there to be either some sort of literal sequence, a first, second, third thing, or at least distinguishments between the thing. We do this thing, and then this other thing, and then this other thing. Somehow they're different from one another, as opposed to the types of problems we're looking at right now, is we're just selecting a group of things. I don't care what order I pick them in. All I care about is what's in the group. So what we're going to do in our next video is talk about how do we actually count this.